FSPro ERC Classes. This short video will provide information about the ERC Classes page in the FSPro Fire Behavior Model and will include selecting a date filter, generating the ERC classes, considerations for modifying the matrix inputs, and other options and selections from the ERC Classes page. Fire spread probability, or FSPro, is a useful tool in assessing probable fire impacts in the long term. As with many models, however, quality inputs are needed to produce quality outputs. In this video, we will discuss the ERC Classes page and the user selections from this page. ERC Classes is one of the required inputs before an FSPro run can be made. To view the ERC Classes page from within an FSPro run, select ERC Classes from the left-hand menu. You will notice that initially a weather station is selected from the drop-down menu. This is the default station based on proximity to the fire origin and should be evaluated and changed as needed. See the video Weather Station Selection for FSPro for information about selecting a station for the FSPro ERC Classes page. Selecting a station is just the first step on this screen. Remember, the goal with station selection for FSPro ERC Classes is to utilize a station that best represents the weather and fuels conditions the fire is likely to experience. After you have selected a station, you must then choose a date filter for the ERC data. Let's begin with start year. A station must have a minimum of 10 years of data to be available for ERC classes. However, more data years is often better, provided the data is of good quality. Typically, 20 years of data is desired in order to sufficiently capture recent variability. Keep in mind that more is not always better if the quality of the data is poor or has large gaps. In some locations, data from the 60s and 70s may not be desired because it doesn't represent current weather trends. Utilize Fire Family Plus and local fire resources to tell you about the station history when selecting a year filter. Next, you will want to review the start and end month and day for the ERC data. Utilize a broad window of data that more than covers the entire fire season for the area. The statistical model used to develop ERCs for the analysis works best with a broad set of data. This is different than the narrow window of data desired for winds. See the video FSPro Winds for more information on wind input selections. If you would like to make adjustments to the defaulted dates, type over or use the calendar symbol to select a different date. The ERC correlation parameters default values of 30 days for the maximum lag and 9 for the max degree of fit are the recommended parameters. See the WFDS Help glossary for definitions on these terms. The next step after adjusting any needed values in the date filter section is to generate the ERC classes by selecting the button Generate ERC Classes. This step creates classes or bins of the data based on ERC percentiles for the given years and dates for the selected station. By default, FSPro classifies the data into 5 categories, at approximately the 60th to 70th, 70th to 80th, 80th to 90th, 90th to 97th, and 97th and above percentile ERC values. An example for this station, the Spotted Bear station, for the years and dates used, the 97th and above percentile ERC-G values are 60 to 72. The ERC-G values in the 90 to 97th percentile bin are 51 to 60. The ERC-G values are 42 to 51 in the 79 to 90th, and so on. Values for the 1, 10, and 100-hour dead fuel moistures and live herbaceous and live woody fuel moistures are averaged for the ERC classes. For example, in this scenario, the average fuel moistures for the 97th percentile ERC and above are 3.9 for the 1 hour, 5.6 for the 10 hour, 8.1 for the 100 hour, 62.1 for herbaceous, and 87.7 for woody. The burn period, spot probability, and delay fields initially default to the values shown here for the 5 default classes. The burn period values represent burning time in minutes. A burn period of 360 minutes is 6 hours. Spot probability values are in percent. As shown here, the spotting probability in the 97th and above class is 15%. Spotting probability in FSPro is calculated the same way as it is in short-term fire behavior, but not the same as it is in near-term fire behavior. The delay values are represented in minutes and represent the delay in time from when a spot fire ignites to when the spot fire begins to grow. For all classes, the default values are 0 minutes. It is important to understand how the model is utilizing this data. As you may know, FSPro will simulate hundreds and thousands of fires, depending on the user selection, based on the forecast data provided and the climatology of the station. For each simulation, FSPro creates a potential season with ERCs and wind for each day. On days when the model is simulating ERCs in the 97th and above class, the simulated fires burn with the fuel moistures and burn period represented in that class. For all the days simulated with ERC values in the 90 to 97th percentile class, the model fires burning with fuels conditions and burn period represented by the values in that class, and so on. If the default 5 classes are not modified, this means that when an ERC value drops below the lowest value, approximately the 60th percentile, but in this case the 59th, and for example in this case a value of 32, no burning is modeled. It is effectively a no burn day in the model simulation. Generating the ERC classes matrix produces the data just discussed. However, often modifications are needed to the data to better reflect actual current fire conditions. The following example is just one way to make potential needed modifications. Select Save in order to initially save the screen so that you can access the ERC stream page. Selecting Save prompts the program to move to the ERC stream page, but if it doesn't, you can just select ERC stream from the left-hand menu. By locating today's date from the ERC stream, you can see what the ERCG value is for the selected station for today, or yesterday, depending on what time of day it is. In this example, the last known value, yesterday, is 51. Now return to the ERC Classes page by selecting ERC Classes from the left-hand menu. Yesterday's ERC value of 51 is in the 90 to 97th percentile class because it is between the values of 51 and 60. Modifications can be made to this class's data based on current conditions. For example, let's say the 1, 10, and 100-hour fuel moistures are fairly representative of today's values. Then we wouldn't make any adjustments here. But if we have field measurements or estimates of the herbaceous and woody values of, let's say for example, 40% and 70%, we can edit the values shown by typing over the current values. Let's also say the current burn period is about 6 hours. Therefore, we can increase the burning time in minutes by 60 minutes to a total of 360 minutes. Gauging whether or not the spotting probability and delay time are accurate can be difficult. Users can potentially get a sense of what values are appropriate by using short-term fire behavior to model current conditions and spotting values, since spotting is calculated in the same way in short term as it is in FSPro. In this demonstration, I will not adjust these values. Now that we have the current conditions accounted for in the current ERC class, the user can make modifications to the classes above and below the current class. Adjusting the values in the classes is not a science, it's more of an art. Modifications will depend on the time of year, the location of the fire geographically, the current fuels conditions, and expected fuel conditions. Consider this. If it is early in the season and green-up has recently occurred, what sort of fuel moisture values and burning times would you expect with higher ERC values and at lower ERC values? If this were mid-season and fuels were beginning to cure, what fuel moistures and burn period values would you expect at higher and lower ERC values? What about at the end of the season, perhaps after a killing frost has occurred? Ask yourself what sort of values might you anticipate in the other classes? What sort of burning conditions do you want to simulate at other ERC values? You can see that these are not questions that have specific numerical answers. However, for example, in general, You would likely expect burning periods to be longer with higher ERC values and shorter with lower ERC values. To aid in communicating your rationale and thought process of the values you selected, utilize the Notes section to document what values you are using and why. We noted earlier that FSPro defaults to produce 5 classes of ERCs, with the lower cutoff at approximately 60%. This too should be evaluated and modified as needed. We also noted that the model works by simulating hundreds or thousands of fires with the burning conditions represented in the 5 classes. If the modeled ERC value drops below the lowest value, in this case 32, no burning is modeled. Consider this when selecting your inputs. The 60th percentile cutoff is an FSPro default that can't be changed. Have you experienced fire growth when the ERC value was below the lowest value? Do you expect fire growth to occur on your fire if the number is below that threshold? If you do, then modifications will need to be made to ensure that FSPro is modeling fire spread at lower ERC values. There are 2 ways to accomplish this. The first method is to simply lower the value of the minimum ERC in the last bin. For example, we could lower the value of 32 to, say, 28, if we think or know that burning is occurring down to that value. Select Recalculate Fuel Moistures to calculate new fuel moisture values. Another method is to add a new ERC class by selecting the Add Row button. The user can define the class by selecting minimum and maximum ERC values and adding burn period and spotting probability. The user can enter fuel moistures or select the Recalculate Fuel Moistures button, and they will be calculated for the new class. By adding a new class, you can have different fuels and burning conditions in this class. The ERC matrix can further be adjusted using the delete buttons if desired. To return to the default values for the station, the user can select Generate ERC Classes button, and the values will be reset to the default values initially used. Be sure to save the page before moving to a new screen, or user-adjusted inputs will be lost. There are a number of other selections users can choose to gain more information on the ERC Classes page. The Download FWX button will allow you to download an FWX file containing the weather data for the station selected that can be used in Fire Family Plus. The Fire Family Plus software allows users to query and review weather data, among other things, which can aid in station selection. The View Percentiles button allows the user to view the filtered data by the full range of percentiles, 1 to 100%. This feature can aid analysts in reviewing the data and determining the appropriate percentile for the lowest bin. The Generate ERC Time Series button will allow users to view a range of possible data that could be used in the FSPro simulation. By selecting the button, the user views a graph that shows the observed average ERC values in gray, the actual current year's ERC values in yellow, and, if used, forecast ERC values in green. The red maximum, gray average, and blue minimum ERC time series values do not represent the values that will be used in the FSPro simulation, but represent the possible range of values that may be used in the hundreds or thousands of simulated weather scenarios. This graph can aid analysts in understanding where the current ERC values are in relation to minimum, maximum, and average values. And when a forecast period is used, it can help to understand the projected initial trend of the values. The Season Ending Graph button creates a graph that displays potential simulated ERC minimum, maximum, and average values, overlaid with the percentile season end, which is defined by the values in the lowest ERC class. The graph is not the same as a season end graph produced using the term model in Fire Family Plus. The term model uses actual season end dates defined by user-defined values to produce a season-ending graph. Note the difference in these products and do not confuse the graph provided in FSPro with an analyst-produced term season-end graph, which uses actual historical observed data and values. As stated earlier, it is a good idea to utilize the Notes section to capture information about selections made to the ERC Classes screen. For example, why you selected the filter period you did, or what default values you modified and why. To do this, select Notes from the left-hand menu. In the box, you can type your notes, and select Save. To review, in this video, we covered selecting a date filter, generating the ERC classes, considerations for modifying the matrix inputs, and other options and selections from the ERC Classes page.